Ready to fire. Fire on 3. 1, 2, 3.
So it's basically boom, boom, boom when we're out on the range.
Jimmy Oxley is a softly spoken mother of 4 and one of the top explosive experts in the world.
Our overall job is to decide if something is detonable or not. We're trying to get ahead of the terrorists and identify some of these materials we need to deal with.
The Department of Homeland Security is funding today's operation. Jimmy's mission: to blow up suspect materials.
A suspect material is a material we think can be used to make a bomb. There are certain properties a material has to have to be detonable. It has to decompose, releasing energy. It has to decompose, releasing gas. And it has to be capable of very rapid decomposition. Those first 2 properties, releasing energy and gas, can be figured out on a piece of paper. That last one, releasing the energy very quickly, that's why we have to go out in the range and test.
Before she can start blast testing, she's got to build bombs filled with suspect materials.
We're not real keen on you showing what ingredients we use there. I'm not telling you the specific materials, basically, because I don't want to help any person that wanted to misuse them. I don't want guidance on how to make a bomb.
Jimmy won't tell us what these bombs are made of, but she is willing to show us how she tests them.
Preparing to detonate, approximately 1 minute.
There's a certain amount of anxiety when we're actually out there testing. This is the big day and it has to go right. It's probably what a bride feels on her wedding day.
Grad student Pat Bowden preps the experimental bomb.
Our test device here basically puts a small amount of test material into the center and then surrounds it with a known explosive.
We call it the booster. We initiate this and watch what happens in witness plate.
This aluminium plate will record the blast and tell Jimmy if the suspect material in the center of the bomb explodes.
Ready to fire. Fire on 3. 1, 2, 3.
We're about 15 meters away.
Okay, it's clear.
Hiding behind a large steel, and I mean heavy steel wall.
It's very shallow.
After the explosion, we're interested in getting as many shots in a day as possible. So we'll just take our video footage or our camera footage and move on to the next shot as quickly as possible. Okay, let's shoot this one fast. When we fill this, we're very particular how full it is. We don't want air bubbles. So the inner material is filled first. We put a plug in it, and then we fill the last bit with an eyedropper. We put something like saran over it so that when we lay the sheet explosive on it, there's no chemical interaction, because that would be dangerous.
This bomb is deadly. If it detonated right now, the team would be toast. So safety is crucial.
1, 2, 3.
It looks like a detonation.
Yeah, it's just not quite as deep.
Fire on 3.
The blasts continue for 3 straight days. Now it's back to the lab to get to the bottom of what happened.
We analyze the witness plates by looking at the dent that they form or the lack thereof of a dent. And we use some 3D laser scanners to determine the surface topography of the plates.
These plates tell a powerful story. They reveal that some of the suspect materials aren't explosive and others are.
When a material in the center is completely inert or does not detonate, we get a large hole.
The hole is created because the suspect material never turns gaseous. Instead, it's driven down into the witness plate as the booster material explodes.
This one here is an example of what would happen if the material in the center was detonable. And so what we see is a completely flat surface.
When the material detonated, it was gone. It went completely gaseous, and so we don't have a jet to penetrate the witness plate.
Jimmy will report these findings to the Department of Homeland Security. Then she'll head back to the range to put more suspect materials to the test.
To tell you the truth, we don't know the boundaries of where detonability stops in some cases. That is indeed why we're doing our job.
It's a dangerous business, but learning how explosives will react in different environments is crucial to that team's work, and it could save lives. Now